Now that you've done perimeter and area, let's also have a look at volume and surface area. First of all, it's important to know that a cube is basically just a 3D square. So where a square was two-dimensional, a cube is three-dimensional. Therefore, when we calculate the volume of a cube, we multiply the 3 dimensions. Therefore, volume of a cube is side multiplied by side multiplied by side, or in short, we can say side cubed. Remember that in a cube, we don't have a length and a width and a depth per se, because all the sides are exactly the same. So this is the reason why I refer to this as side. Now, when we look at the total surface area of a cube, it is once again area, so it's 2D. So what it means is if I take this cube and I unfold it into something flat, almost like when you take a cereal box apart and you put it flat and you make a net out of it, what is the area of that net, or the areas that make up this 3D shape? So it's not the volume that goes inside, it's literally just the outside surface area. So in a cube, it is quite easy because all 6 sides of the cube are exactly the same size. Therefore, the area of one of these squares can just be multiplied by 6. And getting the area of one square, you should know by now, is side multiplied by side, or side squared. And we have 6 of those. Also, the short way that we refer to total surface area, we can say TSA, which stands for total surface area. And remember, whatever your answer is will be centimeters squared or meters squared or millimeters squared, because this is 2D and therefore it has a little 2 at the end. Whereas your unit for volume will be cubed because it is 3D. It is literally what goes inside the shape and not just the outside surface area. So let's try some of these calculations forwards and backwards. Forwards is always very easy, but backwards can be a little bit tricky. If I need to calculate the volume of a cube, and we know that the side length is 4, then I just need to say 4 cubed, or also 4 times 4 times 4, and that will give me an answer of 64, and my unit is centimeters cubed for volume. So in my second example, where 8 is given as the volume and I have to work backwards, I need to find what multiplied by what will give me 8. A short way of doing this is to just cube root 8, because cube rooting is the opposite of cubing, and that will give you 2 centimeters. So these 2 questions were just the forwards and the backwards, both for volume. Now let's have a look at total surface area. Once again, this is the 2D version of the net of a 3D shape. So if I need to do this for a cube with side lengths of 4, then I have to say there are 6 little squares like that. So my calculation would be 4 by 4 for the square, and there are 6 of them, and if you work that out, it will give you an answer of 96 centimeters squared. For the next one, I have a square with size of 2 by 2, and there are 6 of them. So for the second example, I'm going to say 2 times 2, and there's 6 of them, and this will give me 24 centimeters squared. In the third example, they give us the total surface area, but not the volume or the side. So this one can actually be quite tricky. But write down the process like we did for the previous one. I have something times something multiplied by 6, and the answer to that is 216. So I can pretty much work out what this part of the formula is, because something times 6 is 216. Therefore, when I work backwards, I divide, and then I find out that these 2 numbers multiplied together must give me 36. That means that in each block here, I have 6, meaning that my square length is 6 centimeters. So just check that again for yourself. 6 multiplied by 6 is 36. So that's the area of one of the squares on the cube. And there are 6 squares like that, and that is 216. That means that one side length is 6. So now if I'm going to work out what the volume is, I'm going to say 6 multiplied by 6 multiplied by 6, or you can also say 6 cubed, and that gives me 216 centimeters cubed. Let's look at a rectangular prism, which is basically a 3D rectangle. This works pretty much the same way as a cube. The only difference is that instead of 3 sides that are the same, or 3 dimensions that have the same length, in this case we have a length, a longer side, a width, which is a shorter side, and then the depth that makes it 3D. So you might have seen a 3D movie. What a 3D movie is, instead of just the normal length and the width of the screen, which is 2-dimensional, you now have a third dimension of depth. I like to refer to it as depth, but many textbooks also refer to it as height. What you do need to remember is that that is the third dimension, which makes the 2D into 3D, which gives it depth or height, or just a different way of looking at it. It's not flat anymore, but it has depth to it. So working out the volume here is similar to the previous one, where I'm going to multiply the 3 dimensions. So in this case, I'm going to say length times width times depth. You might also be familiar with the formula length times breadth times height. Both of those are absolutely fine. In both cases, you have length. Some people refer to it as breadth instead of width. I think the word breadth sounds a bit like breath. So I prefer the word width. And then depth just reminds me that it's the depth, or the 3D. And I always think of a 3D movie, but it's exactly the same as height. For a rectangular prism, the total surface area is a bit confusing because now there are 6 sides, just like in the cube, but they are not all the same size. The front and the back, however, are the same, so that's why I've drawn them here as front and back that are the same. The 2 sides here are the same, and the top and the bottom are the same. Just be careful if you do these in story sums or in a context situation, because sometimes the box could be open. So just read your question very carefully when you do this. But in a normal situation, we can use the following formula. Length times width, length times depth, and width times depth. So what I'm basically doing, I'm multiplying each of the 3 dimensions with each of the other ones. And in each case, there are 2 of them. So length times width, there's 2 of those rectangles. Length times depth, there's 2 of those rectangles. And width times depth, there's 2 of those rectangles. Added all together will give you the TSA. But don't worry, we will do a nice worked example of this right now. Let's consider these examples here, once again in a table format, just to make it nice and easy. So in the first example, we have a length of 5, a width of 4, and a height of 6. So calculating the volume here is very easy, because I'm going to say 5 multiplied by 4 multiplied by 6, and that is going to give me 120 centimeters cubed, because it is volume and therefore it's 3D. The TSA, on the other hand, is a bit more tricky. So let's do this here at the bottom. And what I need to do in each case is I need to multiply each of these numbers with each other number. So I'm going to start by saying 5 times 4, 4 times 6, and 5 times 6. So that's very easy to write down if you just remember that each number must be paired with each other number, and there's normally just 3 numbers. If that number is double, then you know that they've just indicated that side twice. So here I have 5 times 4, and remember there's 2 of those sides, so that gives me 40. 4 times 6, and remember there's 2 of those, and this gives me 60. Oh, sorry, this gives me 48. And 5 times 6 times 2, this one gives me 60. And if I add them all together, the total surface area here would be 148 centimeters squared. So noting once again that I multiplied each of the 3 dimensions. So I've multiplied the 5 by the 4 and the 6. I've multiplied the 4 by the 5 and the 6. And I've multiplied the 6 obviously by the 4 and the 5. So match each of the dimensions up with each of the other dimensions, multiply them by 2, add them all up, and that will give you your total surface area. Now let's do this process backwards when the volume is given. So in this case, we know that the 3 numbers multiplied together must give me 64, but only 2 of the numbers were given. So when I work backwards, I can just say 64 divided by 2 divided by 8. And this will give me a height or depth of 4 centimeters. Now that I have that answer, I can go and calculate the TSA. Remember, if for some reason you got this answer incorrectly in a test or exam, your teacher will always mark with your mistake. So if you accidentally got 3 and used 3 in your next answer to calculate the TSA, your teacher will mark with this process for you. Okay, so now once again, we're going to match each of these dimensions up with each of the other ones. So 2 times 8, 2 times 4, and then also 8 times 4. And this is a normal rectangular prism. They don't tell us that it's open, so each of these rectangles will appear twice because you have the top and the bottom, the side, and the front and the back. So 2 multiplied by 8 multiplied by 2 will give me 32 because it's 16 times 2. 2 times 4 is 8, multiplied by 2 is 16, and 8 times 4, 48, and that multiplied by 2 is 96. Once again, I'm going to add them all together, and that will give me a total surface area of 144 centimeters squared. Now let's consider the triangular prism, which is just basically a 3D triangle. So instead of having a base and a height, I now also have a depth, or sometimes this is also called yet another height. And it's for this reason that I really like to refer to the part of the 3D object that makes it 3D as the depth, because the height of a triangle and the height that makes it 3D can get very confusing. So if you are one of those people that like to refer to it as height, just make sure that you distinguish between the height of the triangle and the height that makes the triangle 3D, which is then also called the depth. So if I need to calculate the volume of a triangular prism, it works the same way as a triangle, but now you're just going to multiply that by depth as well. So for the volume, we're going to say half times base times height. And remember, this is the perpendicular height. What I mean by perpendicular, the 90-degree height of the triangle. And you now also need to multiply it by the other height or the depth that makes it 3D. What some of my students like to do is they like to put a little arrow there to indicate that that is the depth that makes it 3D, whereas this is the perpendicular height of the triangle. So however you want to distinguish for yourself, just make it clear that there's a difference between what makes it 3D and the height of the triangle. So a triangular prism, different to a cube and a rectangular prism, has only 5 areas. So it has a triangle in the front and the back. So there's the triangles, this is in the front and the back. And then surrounding that, it has 3 rectangles. So there are certain containers that look like this. Those very fancy Toblerone chocolates look like this, and some cheese containers like a brie container. Brie cheese comes in a triangular prism. So maybe you would have seen them. Just remember that there are 3 rectangles and not 6 like in a rectangular prism. So if you would like to work this out for the total surface area, you would have half times base times height, the perpendicular height, and there's 2 triangles. And now you need to be careful because there are 3 rectangles surrounding it, and the base and the height might not necessarily be any of the sides. So in this specific triangle, we're going to say base times depth, and we can say height times depth. And with Pythagoras, we can work out the hypotenuse, because it's a 90-degree triangle, times depth. But if you work with a triangle where the height is not one of the sides, please be careful when doing this. Adding them all up together once again will give me the total surface area. Don't worry, there are some examples of this coming on a little bit later. Let's first consider the cylinder or the 3D circle. So for a cylinder, we have the area formula of a circle, which is pi times radius squared. And now to make it 3D, we're just going to multiply this by the depth, or you can also call this the height of the cylinder. The volume for a cylinder is a little bit tricky because we have a circle, two circles, one at the top and one at the bottom of the cylinder, and then there's one rectangle. Now what makes this rectangle so special is that the length of this rectangle is actually the circumference of the circle, because this wraps around the circle. If you look at my picture here at the bottom, it indicates that this wraps around the circle. So let's look at the formula for the total surface area then. We have pi times radius squared, because that's the area of the circle, and there are two circles. And then we need to add it onto the rectangle, and the rectangle has a length which is the same as the circumference, and I hope that you know that circumference is pi times diameter. So this is basically the length, and then we need to multiply it by the depth or the height or the other side. So here you can write a little note for yourself to say that this is the length, and make sure that you don't confuse depth and diameter here. I like to use pi times diameter for the circumference, because pi radius squared and 2 pi r is sometimes confusing for some people. So using pi times diameter won't get you confused with pi r2 and 2 pi r. But once again, it's absolutely up to you which formula you prefer to use. Let's have a look at some examples of this. So in the first question, the radius is given, but not the diameter. And hopefully you know that radius is just half of the diameter, and that the diameter is twice the radius. So if the radius is 4, then my diameter is 8 centimeters. The height is also the depth that makes it 3D, whatever you would like to call it. So now if we need to calculate the volume of the cylinder, I need to say pi times 4 squared times a height or a depth of 6, and that will give you a value of 301,59 centimeters cubed. Kind of written in that TSA block, but not to worry, we will do the TSA here at the bottom. So for the total surface area, remember that we have two circles. The area of each circle is calculated by the formula pi times radius squared. So I'm going to say pi times 4 squared, and there's two of them. And if I work that out, I get an answer of 100,53. Just remember that some scientific calculators will give you an answer of 32 pi, and you must press the S to D button to get the decimal form out of that. Normally we round off to around about 2 decimal places, but it really depends on the context. So the second part of this, we've already done the two circles here, that's why I multiplied by 2. We now need to do the rectangle that wraps around the circle, and hopefully you remember that that is pi times diameter, so pi times 8, times the depth of 6, and if I do that, I get 48 pi, and as a decimal that is 150.8. Adding those together, I will get a final total surface area of 251,33 centimeters squared. Don't forget that total surface area has the little 2. So in the next question, they gave us the volume, and we now need to work backwards to get the radius or the diameter. So thinking back about what your formula is pi radius squared times depth or height gives you the volume, in this case 2,36. So if I work backwards and I know that the depth is, or the height is 3, and I know what pi is, I can find out what radius squared is. So if you write this down, 2,36 divided by 3 divided by pi gives me an answer of 0,25. But remember that this is now your radius squared. So to find radius, I will have to square root that answer. And if I do that, I get 0,5 centimeters. So over here, for my radius, it's 0,5 centimeters. And remember that my diameter is double. So double, a half a centimeter is 1 full centimeter. So let's have a look at the total surface area for this last cylinder, and we're going to do this calculation here at the bottom. So starting once again with the two circles, I'm going to say pi times my radius of 0.5 squared, and remember there are two of them. And when I calculate this, I get 1,57079. So try and keep as many decimals as possible and only round off your very final answer. So we're also going to work out the rectangle, which is pi times diameter and times the height or the depth of 3. So that is going to give me pi 3, or as decimal 9,425 if I round it off. And adding these two values together, I get a total of 10,994, so it remains 10,99. I know it's very tempting to round 0.99 off to the nearest whole number, but leave the decimal places there. And that is cylinders forwards and backwards. Let's have a look at an easy application question. Here we have a fish tank. You might recognize little Nemo there. And the fish tank is open at the top. So it has 5 glass panels and it's filled to a depth of 20 centimeters. So it's not a particularly big fish tank at all. So in the first question, they ask us to calculate the volume of water. So now remember here, although the glass container has a height of 30 centimeters, the water in the aquarium only has a height of 20 centimeters, and we are working with the water here. So the 3 dimensions I need to look at in this example is the length of 65, the width of 15, and the depth here of 20. So let's write that down. 65 times 15 times 20. And that gives me a volume of 19,500 centimeters cubed, because this is volume. You might know that centimeters cubed, if you think of a tiny little cube, if you do it with your fingers, a centimeter by centimeter by centimeter, that's the same than milliliters. So this is also 19,000 milliliters, or in terms of liters, 19.5 liters. But normally these conversions will be given to you. Now we need to calculate the overall glass panels for this. And remember, in this case, we only have 5 panels. So what I like to do is make little drawings for myself. So I'm going to start with the front and the back. So the front panel, and in this case, remember, we're not going to work with the 20 centimeters depth of the water. We need to work with the glass panels now. So my other dimension here is the 30 that I'm going to work with. I'm not going to work with the 20. So when I look at the front and the back panel, that would be 65 by 30. And there are 2 of them. Now, if I work with the side panels, which is slightly smaller, so side plus side, that is going to be 15 by 30. And there are 2 of them. Ooh, I see I wrote 20 there, times 2. And then my bottom, and there's only one of them because I don't have a top. So my bottom is 65 by 15, and there's 1 of them. So that adds up to 5 different panels. Now let's find our different calculations for each of them. So this first area is going to give me 3,900. The second area is going to give me 900. And my base is going to be 975. All those 5 sides added together will give me my total surface area. So let's quickly type that in on our calculator, and we get 5,775 centimeters squared, because remember total surface area is 2D because it's the flat glass panels. And that's the area of the 5 glass panels. Here is a more advanced application of volume and total surface area, and we're going to look at one question at a time. So firstly, let's just have a look at the picture here. We have a beautiful swimming pool, and there's a wooden deck around it, and there's also some nice square pavers. And we can see on the side picture over here that it has a shallow end and a deep end like many pools have. So the first question here says determine the capacity of the pool, or in other words, how much water this pool can hold. So now this is a very weird looking shape, but like in most cases we can break it up into 2 shapes which are much easier to work with. So let's start by breaking it up into a rectangular prism, and I'm going to color this in blue, and a triangular prism at the bottom, and I'm going to color this in red. So although we only see this front triangle, it obviously has a depth to it, and we're going to fill in all the missing measurements for ourselves now. So starting with the rectangular prism, it seems like we have everything. We have the length of the pool of 7 meters, we have the width of the pool of 4 meters, and we have the depth of this section, which is 1,2 meters. So when I work out the volume here, and you can write your rectangular prism just so that you know what you're working with, is 7 multiplied by 4 multiplied by 1,2, and that gives me a total of 33.6 meters cubed. So that's the rectangular prism done. Now I need to do the triangular prism, but we need to find out all the different measurements because they're not all given. Firstly, this section over here, which is the base of the triangle, is also 7 meters. The height over here is not 2. We know that the top part is 1.2 because we just worked with that, with the depth for the rectangular prism. So in order for it to equal 2 altogether, it means that this section here at the bottom is 0.8. It also has a width of 4 meters, just like the pool does. So we can write this in here for ourselves. So this is your base of your triangle. This is your height of your triangle. And in this case, the 4 meters is what gives the depth to the triangle. It might not be the depth of the pool per se, but if you think of a triangular prism, that is the dimension that gives it that 3D perspective. So let's start by writing down what we're doing here. So the volume for the triangular prism, and once again, it's always just good to write a little abbreviation there so you know what you're doing. In your final examinative trick, it also helps the examiner to know what you were doing. So a very good idea. So half base, our base of 7, our height of 0.8, and in this case, the 4 meters gives the depth to this 3D shape. And that together gives me 11.2 meters cubed. So now that I have the triangular prism and the rectangular prism together, I can calculate the total volume, which in this case will be 44.8 meters cubed. For this question, they did not ask me to convert it to liters, but if you had to convert it to liters, you would have to multiply it by 1,000. So this will be 44,800 liters. Or you can go to kiloliters, which would just be 44.8 kiloliters. In the next example, they ask a very similar question, but in this case, they say that the pool is filled to 10 centimeters from the top. So how much water goes into the pool? This is different to the capacity. So although the pool can hold 44.8 kiloliters, it is not full to the top. Sometimes it's being asked why this is the case, and if you've ever climbed into a swimming pool, you will know that if it's filled right to the top and you climb in, that it actually spills a little bit over on the side. So the pool's never full to the top. There are two ways of working this out. You can either do the same calculation we did earlier, but just have a depth that is slightly less. So what I mean by that is the 1.2 would be 10 centimeters less, or you can work out the little bit that is left out and subtract it. In most cases, I find that just making this length over here a little bit less is probably the easier method to follow. So when I need to subtract centimeters from meters, it's always good to do a conversion. Seeing that my final answer needs to be in meters, I'm going to convert my 10 centimeters to meters by dividing by 100, and that gives me 0.1 meters. So it means that this depth over here of the pool is not 1.2 anymore, it's now 1.1 meter deep. Remember that this does not affect the triangular prism here at the bottom. The triangular prism will still be exactly the same that it was before. It's just your rectangular prism will be a little smaller because you haven't filled the pool to the top. So we can rewrite the calculation that we did previously by saying 7 times 4. But instead of having 1.2, you will now have 1.1. So that will give you 30.8 meters cubed. Your triangle will be exactly the same than it was before, so that's half times 7 times 0.8, if you still remember that from the previous page, multiplied by 4. So your answer will once again be 11.2 meters cubed. And now instead of having a volume of 44.8 like you had for the previous question, this one is only 42 meters cubed, or 42 kiloliters. Because you haven't filled it all the way to the top, but you filled it 10 centimeters from the top. This specific pool has beautiful square pavers all around it, which you can see here on the picture. Do remember that the pictures are never drawn to scale, so please don't go and try and count the little pavers here. It's just here to give you an indication of what they look like. Because the question now asks you to calculate how many pavers go around the pool. So what you need to realize is that in the corners over here, you have 4 pavers. And then there are square pavers fitting in the length of 4 meters and fitting in the length of 7 meters. So don't forget about those 4 corner ones. So what I will need to do is you can either convert everything to centimeters. So say 7 meters equal 700 centimeters. And then say 700 centimeters divided by each paver length of 20 centimeters, which will give you 35 pavers. Or you could work in terms of meters, and then you just have to work with some decimals, but both methods are exactly the same. The same with the 4 meters. You can convert that to 400 centimeters, and then also divide the width by the paver length of 20 centimeters. So you will find that there are 20 pavers in the width. So now if there are, and let's write it in here on the drawing, if there are 35 pavers in the length, then it means there are also 35 on that length. There's 20 in this length over here on the width. It means there's also 20 in this width over here. So altogether you would have 35 pavers in the one length, 35 pavers in the other length, 20 pavers in the width, 20 pavers in the other width, and then 4 pavers in the 4 corners. And altogether that's 114 pavers. We've looked at the capacity of the pool, we've looked at the pavers around it, so now it's time to look at the decking of the pool and work out the area that needs to be covered with decking planks. So let's consider the drawing. They give us here that this has a width of 1.1 and here it has a width of 0.9, and we can assume that it's the same on the other side. They also tell us the interior length of the pool here and the interior width of the pool, and we know that those sections are 20 centimeters. So let's try and work out what each measurement will be. Starting with this long section here at the bottom, I know that the middle is 70 centimeters. This paver over here is 0.2 because 0.2 meters is the same than 20 centimeters. And I know that this section over here is 0.9. Adding it all together will give me the total length of this section. Once again, it really helps if you draw on the picture, if it is at all possible to help you to calculate this. So in this case, I can see that it's 0.9 plus 0.2, the 20 centimeter paver, plus the inside length of the pool, which is 7 meters, plus the other paver, square paver on the other side, plus the other length of the decking. So my total length here would be 9.2 meters. So let's use this in our measurement now for this bottom plank. It has a length of 9.2 and I know it has a width of 1.1. So for this bottom section, I will get a total area of 10.12. Also remember that I will have to add this twice because there's one here at the bottom and one there at the top, but we will do that a little bit later. Let's first go to the side one, and let me just use a different color to distinguish here. So now we are working with this section over here. And let's find out what that will be. So we know it has a width of 0.9. All I need to find is what is this length over here. We know the inside of the pool is 4. And we know that the paver at the top is 0.2 and so is the paver at the bottom. So in total, that gives me 4.4 as my length. So 4.4 multiplied by 0.2 gives me 3.96. So it means this section over here has an area of 3.96 and this section over here. So now I can go and add them all together. I can say 10.12 for the bottom parts, 10.2 for the top parts, plus 3.96 for the left side and 3.96 for the right side. And that all together will give me an area that needs to be covered by decking of 2.16 meters squared. Now we get to the monster question. And for this one, you will need to imagine yourself standing inside the pool and painting all the sides. Because this is exactly what this question is asking. If you were to paint this pool with a special waterproofing paint, what is the area that needs to be painted? So let's start with something easy, and we start with this rectangular wall here on the side. In this case, the shallow end of the pool has dimensions of 1.2 meters by 4 meters. So it means that the area for this would give me 4.8 meters squared. Let's have a look. If this is the shallow end of the pool, let's have a look at the deep end of the pool. So if you can imagine this section over here, the deep end. So that will have dimensions of 4 meters by 2 meters, which gives me 8 meters squared. Now we need to go onto the side walls, and for this section, remember that what we did earlier, we divided it into a rectangle and a bottom triangle. So let's work with a rectangle first, remembering that I have one on both sides of the pool. And in each case, it would have a length of 7, and then it's the same in the depth over here of 1.2. And remember, there are two sides like this that are exactly the same. So this altogether will give me 16.8 meters squared. I now need to continue to the triangular part at the bottom. And if you remember this from the volume question earlier, you would remember that this has a height of 0.8. and a base of 7 meters. And there's also 2 of these sections. So half times base of 7 times depth of 0.8. And remember, there's 1 on both sides of the pool. So that gives me 5.6 meters squared. So now if you can imagine yourself standing inside the pool, you've painted the shallow end, you've painted the deep end, you've painted the 2 sides. So the last thing that remains to paint is the base or the bottom of the pool. There is, however, a section of information that they haven't given you, but it is possible to calculate. And this is this long length over here, which in this case is also the hypotenuse of this orange triangle. So if I say the word hypotenuse, you should remember Pythagoras. And because it is the long side of the hypotenuse, it means I need to add in this triangle. So using the information from my orange triangle, I'm going to say 7 squared plus 0.8 squared. And if you watch the Pythagoras video, you know that I like to put the whole thing in a square root sign so that it's one step. And this gives me a length of 7.05. So I'm going to fill this in on my drawing so that I know what is happening. So if the length of the base or the bottom of the pool is 7.5 and the pool has a width of 4 meters, then it means that that bottom rectangle will be 7.05 times 4. And that gives me an area of 28.18. So let's just double check that we have everything. I've started off by looking at the shallow end, which I've done. Then I've done the deep end, which gave me 8. Then I did the 2 rectangular prisms. They were on both sides, on your left and right, if you imagine standing in the pool, as well as the triangular prisms, which was at the bottom of that rectangular section. Then we also did the base of the pool, but I used Pythagoras to get that. So the only thing that is left over is to add them all together. So if I add it all together, it gives me 63.38 meters squared. And that is the whole area that needs to be covered with waterproof painting.